All right, I think now is the goodest time ever to start. First, again, thank you everybody who hopped on a webinar today, Wednesday. Welcome to Customer Data Science Online Edition. I hope everyone's doing well and safe during these crazy times. Obviously, my name's Adam Brownell. I've been hosting the last few. It's great to see in the chat some familiar faces, some new, some old. I hope you all get something out of this that's enjoyable. We have two great speakers today, Siyang and Mo. Both of them are from Retina AI, who hosts the CDS. Retina AI is a customer analytics startup from Santa Monica. We focus on customer lifetime value calculations, which are aptly appropriate in this crazy purchasing time of customers. And so modeling customers is the game. I'm sure they'll talk more about that in their presentations. But yeah, without further ado, I would like to introduce the first speaker, Siyang. Siyang is a data scientist at Retina who seems to be on a tropical vacation right now. Pretty great place to social distance. Yeah, Siyang, you have the floor.
Lovely. All right, let me share my screen. Adam, do you see it?
Yes, I do.
Cool. So thanks for tuning in. Today I'm going to be talking about data science from a business perspective, which is something very relevant to us in the customer data science space. And especially when I was thinking about this presentation and building the slides, I realized a lot of these talking points are pretty intuitive and almost basic at times. But I know, at least for me personally, when I'm really in the weeds, tuning a model or wrangling data, I often forget these things. And so these are some good things to keep in mind, and maybe hopefully you'll learn something too. So a bit of background about me. I studied math and economics and computing at UCLA and got some good theory on the statistics and math behind data science. But I figured I wanted to learn how to apply my skills. And so I went into UCLA Anderson's business analytics program to try and learn how to apply these things to the real world. And then after that, I started working at Retina AI as a data scientist, and I've been there since January. And so one thing that I was always wondering as I was getting into this career is, what is a data scientist? Because there are so many different job postings and like job descriptions of what data scientists do, and it's very unclear at times. And here's a fun video of this is like a parody rap battle somebody posted, but you like to think that data scientists are people that just build models and do hardcore stats, but really data scientists can be all sorts of things. And so I've seen data scientists refer to a very wide variety of things. Anything in this list, and often a combination of all of these above. But all of these roles actually have a lot in common, despite how different they may seem. And so one thing is, all those kinds of data scientists leverage data to help the business. They also use empathy to understand the business needs and stakeholder needs. And then they need to communicate this data or the insights from this data back to these internal, external stakeholders. And even if you're building data science products, you still need to be able to communicate the data to other people in the company. And so data scientists in this regard often act as translators, interpreting the insights from the models and the data to the business leaders. And here's a chart of some of the really important skills for data scientists. And most of what I'm going to be focusing on is these two on the edges, the communication and business, which often go unspoken. So the first point, data scientists use data for business gain. Whether it's delivering insights or building products or conducting cutting edge research, the whole purpose of data science is to use data to impact the business. And not only that, but success is also measured by this impact on the business. And so that's the primary reason why we're here, as opposed to, if we're in academia, we want to use research to discover some new thing that might benefit the world. But here we are trying to impact the business. And to do that, we need to understand what actually the business needs. So we need a very deep understanding of the business problem before we try to apply stats or modeling to it. And so to do this, we need to also understand the stakeholder or customer, especially in customer data scientists or customer data science. But we'll also need to understand the stakeholder who maybe planned this project. And this requires having empathy. Obviously, as data scientists, we love diving into the data and doing modeling and analysis. But first, we need to figure out why we're even doing this, because there's some contextual things related to the business problem that we could not just find in the data. And so a quote that I used to see all the time when I was a kid is, "Don't judge a man until you've walked 2 moons in his moccasins." And this, we're talking about empathy. Unfortunately, at work, we don't really have the time to walk very long distances in space. So the next best thing we can do is to actually talk to people and try to understand them. And so to do this, you need, what I would consider product management skills. Now you might be thinking, why would I need product management skills? I'm a data scientist. Well, what I really mean is soft skills in regarding figuring out what people want and why they want it, and then how I can use my skill set to properly address that. And so before starting a project, we have to ask the right people the right questions regarding what they need, and try to figure out what they want and why they want it. A good way I've done this in the past is using user stories to try to put ourselves in the customer or user's shoes. For example, you could say, I am a product designer who wants to know if my feature helps boost retention. Or I am a marketing manager who wants to prioritize my channels. And then by us putting ourselves in their shoes and coming up with that statement, we can try to understand who our customers or our people we work with are, what they want, and how we can help them with that. Another thing I've seen in the product management world is doing user research and user interviews to try to understand on a deeper level what the customers are looking for. Of course, you don't always have time for this, so having conversations is a good start. Even just thinking about it is a good start. And another really important thing when thinking about data science from the business perspective is when we're delivering insights, we have to really think like, what is the actual impact of this? Like, why does this even matter, right? Because we might be thinking our model's pretty good. We worked mostly on this model and it works, it's accurate, but ultimately, what is the impact on the overall business unit or the overall product or on the overall customers that we're actually benefiting with this? And so example, you might say our customer segmentation has a silhouette score of 0.8, which means literally nothing to somebody who doesn't know what a silhouette score is. And so we have to ask ourselves, so what? Well, so what? We can accurately segment our customers into clusters. Okay, so what about that? Like, why does that matter? Well, these clusters let us group customers together in a meaningful way that can be easily described and accurately. Why does that matter? Well, now I guess let's say we can specifically target marketing campaigns to these high value segments. And that matters because we can save marketing costs and capture high value customers. And that matters because we increase ROI and cut costs, which helps the business. And you never want to be in a position where you're presenting a new product or model or analysis to a business stakeholder and they ask you, so what? And you're like, I don't know. Or worse, like nobody asks you that, and then you deploy a model or an analysis that ends up not being used and you have no idea why, because you built a great model, right? So because of that, this process needs to happen very early in the life cycle of data science work. And hopefully it happens all the time where we ask ourselves, what is the purpose of this? And we ask ourselves this many, many times till we get to like the root cause of why we're even doing this analysis in the first place. And so when we've discovered something, we also need to be able to communicate these insights to people. And to do that, we need to understand them further. So generally, storytelling is how we can communicate data insights to other technical or non-technical people. And then we need to put ourselves in the listener's shoes to understand their context and what they know about this in order to give them insights that make sense. So for example, instead of telling somebody that your model has AUC of whatever, we can go through that same process before, asking ourselves, so what, many times to get along that story of like, okay, our model's accurate. This lets us find out these things about customers, which lets us take these actions, which will help the business in this way. So that's really important to keep in mind. And then this applies to launching products too, because we are not, in that case, we're not just delivering the analysis, but we're delivering a product that continuously delivers the analysis as long as the user knows how to use it. And then oftentimes after we've launched a product like this, we need to give insights afterwards to prove that it succeeded. And so then we need to think about the impact on the business after that. Well, hopefully we thought about the impact on the business before when we were designing this product in the first place, but we had a goal in mind, which is good. And also, once you've finished delivering, it's always good to recognize that your users and your stakeholders had a hand in the success if you had conversations with them in the process. So here's an example I'm going to walk through. So the example is, let's say we're building a churn model for our company. And so maybe I am the head of customer success. I want to know how I can stop people from churning so that my team doesn't devote resources to like a lost cause customer. And so my stakeholders would be internal marketing and customer success teams. And the question is, how can we combine our data science with empathy to deliver impact to this customer success team? And so we have to ask ourselves, these are just some example questions we should ask ourselves or ask other people in the company. Who's going to be using these model predictions? How are they going to be using them? What decisions will they make with these predictions? And what can they make, right? Like what's given the stakeholder, what is in their power to actually do with this knowledge? And how can we wrap this model with analysis so that it's really easy for them to use and interpret? And also just thinking about the customers in general, because we're building a churn model, right? So how does the customer feel when they're about to churn, and why would they do this? Of course, these are things you think about when you're doing the data science. But also, what specific characteristics about our business model affect the customer's decisioning process on whether or not they're going to churn? For example, like say we work at like an ed tech company that does online courses, like subscriptions. Well, people probably churn all the time and they come back. So that's going to really heavily affect like how we think about our churn model. Or let's say the CS lead or the customer success lead, they actually want to know who's on the fence, not who's going to churn, because they think if they devote resources to somebody that's going to churn anyways, that's like totally, that's a waste of time. So we want to either maybe model who's on the fence of churning, or do some kind of like causal data science modeling, or some kind of experiment to see the incremental effect of the customer success efforts. Maybe that's what like they actually want, right? Maybe they don't want a churn model, they just want to be able to know who they can save. And so by having conversations like this and like planning this out in advance, we can save ourselves a lot of work and also get to the best solution as soon as possible before we even get our boots in the soil and do data science. Also, these examples work too if you're doing these as like a B2B service to a client company. Actually, I've done this a couple times. So another example is a little different. So let's say we're building a recommendation system internally for like a product feature. And so the stakeholders here would be the internal product team. And so we still want to figure out like how we can combine data science with empathy and understanding of the business and of the other people in the business to deliver the most impact possible, because that's what we care about, right? Is delivering impact. So we need to figure out like how we can provide user experience while pointing customers to the items we want. This is something that maybe you don't think about all the time with recommendation systems, but let's say like we want to optimize supply chain internally. And that's like a separate internal goal outside of just showing the customers like stuff they might want to see. And also, how can we prove that this benefits the company's goals? So this kind of ties into like figuring out other goals outside of just building this feature. Like, do we want to do something? Do we want to point people towards certain products that we offer? And then, of course, there's the external like customer questions we need to figure out and use empathy to try to understand, which is like, what do different types of users want out of their experience, using our product, and what are they looking for, and what do they want to see? Maybe people actually want to see things that they weren't going to see otherwise. I don't know. That's something that we need to think about, right? And so another thing about like, just to go back to showing internal stakeholders how this benefits our company's goals, we want to help them help us help them. And by that, I mean, like, we want to help the leadership understand what we're doing benefits the mutual goals that we have as a company. And so we have to understand them in order to do that. We need to understand how we can translate these data insights to communicate to the business stakeholders, the leadership, in order to make a decision that will benefit everyone. And we can't do that if we just show them the data science, right? We have to also be able to speak their language. And so ultimately, it's really important to remember that data science is a team game. Unlike software engineers who generally, they depending on the role, they could build something out of nothing, right? Like, I know Adam has built some cool apps out of nothing just with his hobby software engineering skills. We generally do not do that as data scientists. If you are a customer data scientist who is building something out of nothing, that is super cool. Please give a talk at CES. But generally, we need data to do our work. We need customers, especially in the customer data science world. Generally need an existing business, and we need to coordinate with other people in the company, these other stakeholders, to try to do the best job that we can. And because we need all these other functions to succeed in our work, and often, honestly, so much of our work is helping other functions succeed more, it's really important to be able to understand how we can communicate with them and how we can communicate what we've learned from the data to them so that they can make they're equipped to make the best decisions possible. And so we have to understand both, how to work with data, but also how to work with other people. And we have to understand where they're coming from and what their goals are. So, those are some things to keep in mind. And that's all I have. Thank you.
Awesome. Thank you so much, Siyang, especially for plugging my engineering skills. Yeah. They are very hobby at best, but thank you. I forgot to mention at the beginning, so I apologize, but there is a question and answer element of CDS, but also in the Zoom features, you can click the Q&A button and
I see it.
Type some. As an audience member, if anything, Siyang mentioned was interesting, you want to dive a little deeper, we still have some time to kind of chat about his presentation a little more, or his insight. Obviously, Siyang being very well versed, having both the technical and business degrees related to these things.
Sure. Yeah. One thing somebody asked is if I could go a bit more into how user stories can help us figure out like what people want. Because generally this is a thing that product managers or even like people in the like product design world do, and how that's really relevant to data science. So here's another example. Let's say I'm a sales director who wants to see how good my leads are, right? So then a data scientist who wants to help, like a data scientist who wants to help me, who I find to come help me with this, if they don't understand that where I'm coming from, like that I want to be able to give my sales team these leads that are scored in order to like properly prioritize them or send them to different channels. If the data scientist doesn't understand that, they can't, there's like too much ambiguity in this problem to build a model directly. Because yeah, we could do all kinds of like classification or even like come up with a lead scoring score just given the data. But if the data scientist doesn't understand the day-to-day of like how the stakeholder is going to use these, right? Like, then this analysis might not even be useful to them. So that's something to keep in mind. So another question, thanks by the way. What are your recommendations on translating business stakeholders' definition of success into data science metrics? So I think there are two sides to this. One is it's important to be able to translate data science metrics into ROI, which I guess I did talk about with like the this like customer segmentation example. But you're right, it's really important to be able to translate the ROI into data science metrics in order to be able to, when we're planning this project, be able to like have trackers of success before we launch it, right? Because we won't really know ROI until we've like actually deployed this model and have seen it work for a while. So one thing that is useful is to follow this kind of like so what path when you're thinking about your data science metrics in the first place, and then see how you can get from there to ROI through, and this is like also gives you a useful story to tell. But then now that we've walked ourselves from the data science metric to ROI, we can like revert, like go in reverse on this path to say like, how can we translate these success metrics? How can we track ROI through these data science success metrics? Does that make sense? I realize you can't respond. And I think.
Siyang, do you see the question that was posted in the chat session as opposed to the Q&A session?
No, how do I view the, oh, I see it. Cool. Okay, so the question is, I am a BSA working to transition to a data-heavy data science position. And in addition to doing projects at work and personal capstone projects with Python skills, what would you recommend to focus on for successfully transitioning to a data science role? That's a great question because I guess I do have some experience like going in this direction. And I would say a really important thing to practice is like being able to present your findings and communicate your findings to a non-technical audience. Because even if that doesn't end up being your job as a data scientist, like say you're more in the back end, like machine learning engineering, it's really critical to be able to communicate like communicate data science concepts to people that may not be like directly familiar with that, because you'll more likely than not be working with those people all the time, and being able to communicate with them and express like things that you've found with your data science work, or be able to understand like what their opinions on how this project should work, or like what they want out of this project. It's really important to be able to understand that. So practicing like presenting and communicating your insights is really important.
So Siyang, it looks like Sheila has a follow-up to your first question, and then I think that will be our last question for this segment.
Got it. Okay. So yes, but I'm interested in learning about techniques that we could use. And that's in regards to translating ROI into data science metrics. Right. So one thing we could do is do like an A/B test in order to figure out what the ROI could be from making this change. And of course, like that is something that would have to happen like after we have already developed like a working version of the model. But that like is something that, data scientists often use to try and at least get some sense of ROI before we jump full in and like launch this full scale into production. But yeah, we could do something like an A/B test for that.
Great. Actually, Siyang, it looks like one question snuck in there. You want to go ahead and answer that, and then that'll be the last one. We'll cap it. We'll cap it there. Any other questions? Please just reach out to Siyang after the event.
Yeah. So this question is, when working with different kinds of teams, like an engineering team or a product management team, how different is it interfacing with those teams in terms of data storytelling? And from my experience, I think it is different in the sense that, they're coming from a different place. Like the engineering team has different, they have different levels of agency, or like different kinds of agency regarding the thing you're building. So maybe engineers, like if you're working with data engineers, for example, they care more about like, how will this model scale in production, which, this is something Mo's gonna talk about soon, so which is great. But they might care more about how your model will interface with the rest of the software architecture, rather than things like timelines or business goals. But ultimately, it still is really important to be able to communicate your data science findings in a like non-data science way, because even if they're an engineering team, right, they don't spend their time like working with models all day. So we still need to be able to communicate with them in a common language. And that still ends up being the business, because, we all work in the same business. So we understand like the business goals in that way. So I would say that's how it would be different interfacing with those teams.
Awesome. Thank you so much, Siyang, for your presentation, and thank you to the audience for your insightful questions. Again, if you have any more for Siyang that pop up during Mo's conversation or late in the night tonight, feel free to reach out to Siyang through LinkedIn or however. I'm sure we'll pass on some contact information afterwards. But let's transition over. Our second speaker is Mo. Mo is a data engineer from Retina, but unlike Siyang, who is on vacation, Mo is all business with his Retina background. And yeah, I'm excited again. If you have any questions that pop up for Mo during the presentation, feel free to type them out in the Q&A, and then we'll have a Q&A section at the end of Mo's presentation. But please give it up, clap. We can't hear you, but please clap for Mo.
Oh, thank you, everyone. All right. So first, hello, and thank you, everyone. Thank you especially to Adam, Carol, and Taylor for organizing CDS every month. It's a great place for a data scientist to chat, share knowledge, and gain insights on the industry from the inside. So I'd like to remind everyone that I will be taking questions, not only at the very end, but also along the way. So feel free to post your questions in the Q&A section. I'll be glad at it as I'm presenting. And if I don't get to your question as I'm speaking, I'll definitely get to it at the end. So feel free to post there. And I think we're good to start. So what I want to talk about today is how data scientists move their models from research and development to production. And I'm gonna tell you about some common problems data scientists face or data teams face, because data scientists and data engineers are best working together in one team across their projects, and how you can deal with them. So a very quick outline of what I'm going to present. So these are the 5 problems I'm going to talk about: misaligned performance metrics, hidden dependencies, poor performance in production, model drift, and online training and monitoring. A little bit about me. I'm a data ops engineer at Retina AI. Before that, I was a software engineer for a few years, partly in the pharmaceutical industry and partly in the oil and gas industry. In both cases, I was designing systems for production, so they were business critical, that they stay online all the time. I'm also pursuing a master's degree in computer science right now in machine learning. And actually, when I first started pursuing this degree, I thought I was going to become a data scientist. I was like, this is great. I want to become a data scientist. When I'm done with this is going to be a great transition in my career. But when I actually started working on data science projects, I realized, oh, this data science and statistics thing is great and all, but I'm actually really interested in all the systems that go along with it, that make it happen, as in make it into a data product. So I became a data ops engineer. Let's see, how to reach me. LinkedIn is the best way. I also share a few open source GitHub projects. You're welcome to look at these. And I put my email in there. Hopefully that's not a bad idea. LinkedIn is best. So onto our problems. So the first problem is misaligned performance metrics. I'm going to tell a story. So I'll try to keep this fun and interesting throughout the presentation. So we're gonna go through, I'm gonna tell you a story and we're gonna relate it to every one of these problems and their solutions. So this is the story of Bob. Bob is a data scientist. Bob works at a company called Zoom, and Zoom is a video conferencing company that offers their customers a suite of video conferencing products. So they offer products for online meetings, products for webinars and meetups. They even offer products for virtual events, kind of like this, kind of like Zoom. So they have 2 main offerings. They have a free product where customers can set up meetings for up to 45 minutes. And then they have a $20 a month offering where customers can set up the same events, but they can set them up for an unlimited time. One day, Bob's manager asked him to create a upsell prediction model, and that model is supposed to identify when a customer signs up for their free product, as soon as possible, identify if that customer will purchase the paid product within 90 days. So that's a very, that is the business problem. So Bob, of course, takes the business problem and translates it into a data science problem. Luckily, it fits in very well as a supervised learning problem. So this problem fits in as supervised learning with 2 classification classes. One for the people who signed up and purchased in 90 days, and the other ones for the people who signed up and did not purchase in 90 days. Now, with all the problem defined, Bob goes and starts doing his data science. Of course, step 1 is to collect, clean, and process data. So he collects data from other services within the business. So they have a product service that stores where all the product information is stored. So the event types would be stored there. There is a user service that has tables with user information, and he would need that to know who converted, who didn't convert. And then there's a billing service that stores all the orders info, where he can get information about of the users, how many of them did buy and did not buy. So he takes all of these data sets from these different sources and combines them together to generate a modeling data set for his project. Let's see, and he even goes on and does a few iterations of different models with training and testing, and then cross validation, and he gets some preliminary results. So he gets an accuracy score of 0.85, a recall score of 0.77, and an AUC score of 0.82, which are not bad. They're okay. So this is 2 weeks in. His manager comes to check on him, and he asks him, "So Bob, how's everything going? Do you have everything ready for me? Give me some good news." And Bob says, "I have great preliminary results. I managed to collect all of this data, and I even went and treated the model, and I have this accuracy score of 0.85, which is not great, but it's a good initial result for me to keep going." So that's exactly what he did. For the next 2 weeks, Bob goes back and he tries some more sophisticated models. Maybe he tries like an ensemble configuration of different models together. And maybe he reads a research paper about some deep neural network configuration that's brand new, and he tries that, and his results increase. So he gets better results. He gets an accuracy score of 0.92. He gets a recall score of 0.89. He gets an AUC of 0.91. These are pretty good. These are pretty much ready to go for production, depending on the business use case. He spends 2 more weeks doing this. His manager comes back at the end of 2 weeks and asks him, "So, Bob, how are things going? Do you have any more good news for me? Are you ready to go yet?" And he said, and Bob, of course, replies and says, "I have great news. My advanced modeling bared fruit, and I have this very high accuracy score of 0.92. And of course, his manager said, "Is this the best we can do? Can we do better?" And Bob never vacillated from a challenge. And he goes, "Well, I can definitely get a better model out there. I'm the best data scientist I can be. This is what I am here for. I'm not here to build mediocre models. I'm here to build the best models I can build. And give me a few more days and I can definitely get it up to almost 100%. That's exactly what he did. So Bob tries again for a few more days, and he does hyperparameter tuning, and he tunes his model to get the almost 100% accuracy and recall and AUC. And he's extremely excited to share these results with his manager and to put his model into production. But he gets an email on the day that he wants to share his results from the product strategy team, and the email says that the product strategy team decided to look at the product catalog, and they decided to scrap the free product entirely because they thought it wasn't worth investing in, and they wanted to keep only the paid product because the paid product was already generating enough revenue for the business. Now that's great news for the business. However, it's bad news for Bob's model because if there's no upselling, they don't feel an upsell model anymore. And so we come to our first lesson, and it's don't chase perfection, good enough, fast enough. And what I mean here is if you, the business doesn't really care too much about how perfect or how accurate the model is, as long as it performs well and it's done in time where the business can use it, then the business would prefer to use that model. A lot of data scientists are, you see your AUC scores, you see these accuracy scores every day when you're modeling, and your task day to day is to get these scores higher, but you have to look at on a very high level, your actual target is to get a model that is working. And good enough here depends on the problem. So if you're creating a model for, let's say, financial fraud detection, then a 0.8 AUC might not be good enough. But if you're creating a model to market to acquire customers, a 0.8 score might be okay. You could bear being false, be positive or false or negative a few times. All right. The second problem is hidden dependencies. So let's go back to the story and let's pretend that Bob did have a model up in time that was simple enough and that fulfills the purpose. So to move a model from R&D to production, he works with his teammate who's a machine learning engineer, and together they package that model up into a service, and that's standard for moving models to production. You package them in a service, and you containerize them, and you expose them to an API endpoint. The details are not important, but so they do that, and everything seems fine. However, a few days later, the machine learning engineer gets an alert in operations in the middle of the night that the service isn't returning any results. So that's what you get back when the service is running and they don't know what's going on, and the logs don't say anything, and they have to investigate it as an incident. So they do that, and they identify that the product service happened to add a new type of event called a festival event in the past 2 days, which is fine usually. But what happened on the model side is, because the model takes features from the product service and it converts the categorical features that are event type into numerical features by a process called one-hot encoding. So it will take these events types here and convert them into numbers by using more columns. So, and when the product service added an event, it seemed like they didn't change the schema. It seemed like everything would be okay. But in the model service side, a new column was added, and the model couldn't handle that. And therefore, and that is why the service failed. Now, to avoid this, we need to ensure that our feature creation process is robust against changes in the underlying data. It's very easy for us to trace code dependencies, because if you have a code dependency, you can track it in logs, and you can track it in dependency lists, and even Git can track it. So if you have GitHub, it's very easy for you to track code dependencies. However, we don't have systems in place right now as an industry to track data dependencies accurately. And until the day comes that we are tracking data dependencies without thinking about it, we have to ensure that our features, after they're created, they're robust. So an example, for example, to make this more robust here, the model service could write code to say, if my schema changes, ignore new features. Or if I'm one-hot encoding and I get a new set of encoded features that I do not expect, log it and ignore it for now. And that way the model service will still work, but they will log that, oh, something could be improved here. So someone can see it in a week, in a month, when they look at the logs, but the system will keep going. Next, poor performance in production. So this is a data scientist. It works on my machine. And if we go back to the problem, let's say Bob, our story, sorry, if you go back to our story, let's say they fix a problem in production and they deploy another model that is a lot more robust into production. Now, once it is deployed, it is possible to come back and do more testing with new data, because now that you're in production, you're getting more data, and Bob is able to reevaluate the model. And you expect the model results to be the same in production as they were in development. But in his case, it was completely false. It was the accuracy score went down to like 0.55, which is very close to chance, which is highly unexpected. And diving deep into this problem, this is a hard problem to solve, but these are possible solutions for you to help you find the root cause. Sometimes we have locality issues when dealing with models. So let's say you're working with a data set that is from an international customer base, but you deploy your model only on the US customer base. That could mean that the distribution you trained on is vastly different than the distribution you're predicting on. Meaning, and because models don't really localize very well, you could get vastly different results. Locality issues are also present in temporal data. So let's say you are predicting for a business, and that business has been around for 10 years, and you're like, oh, I have 10 years worth of data. Let's use all 10 years. But 5 years ago, the business had like a hard pivot, and their business looks nothing like it does 5 years ago. The data you use from the past could be more noise than it is actual results. So that could blur your data. Let's see. Oh, this is fast. So another thing to worry about is seasonality. So e-commerce businesses have notoriously long seasonal cycles. You have all year long, you would have average spend, and then the holiday season comes, and this spike comes in the buying and from the business. And to model that in a machine learning model, you need multiple years of data. So be very careful with seasonality. You can send a model out with 1 year, with 11 months of data, and you happen to deploy it around Christmas time, and it will predict things that are horribly wrong, because it's never seen holiday sales before. A third thing that could be wrong is your sample distributions and your population distributions. If you are using a sample of your data set to train, try as much as possible to have that sample represent the population you're going to be predicting on. The best way to do this is make sure your samples are completely random. So if you're doing a train test split, or if you're taking samples from a big population, don't take the top X, or don't slice your data. Try to make sure that you're using a random sample, and that can mitigate against this last one. So be aware of locality, seasonality, and sampling issues. These can all be called data biases, but these are possible ways. These are things you need to think about when you're developing. The fourth problem is model drift. So when you push a model to production, the model quality will drift over time. This means that the predictions are going to degrade. And this is actually not really a problem, because all models drift. So even whatever model you put in production, it will eventually drift. And I'd say that good models will drift faster. And there is a reason for this. So if you think about why we deploy models and why we use machine learning models in production, it's to use them to cause some business change. And therefore, the business will not look the same as when you train the model. and therefore, of course, it will degrade because it's not predicting on the same business. So it's like a cycle. You train a model on the current state of the business, you deploy the model to production, and the business uses the predictions of this model to change the state of the business, and therefore the model drifts. So if we come back to Bob's story, if they had used the model in production to sell, to market to the customers that the model suggests that they are not going to buy, if they heavily market towards them, they're going to start buying. And therefore, the business state changes. So the model will break itself, basically. I want to summarize it and say, like, in machine learning development is different than software development, because if you write software, you are automating business decisions. So you have some business logic, and you create software to automate that logic. That's why you can send it and keep it running for years at a time, and you can guarantee that the results are the same. But if you are doing machine learning development, you're making the machine take the business action for you, and therefore it's heavily dependent on the business, the underlying business, and its state. So the rule is, if you deploy once, you're definitely going to deploy multiple times. Our last problem for today is issues with online learning and model monitoring. So to deal with this cycle of deployment, we can create an automated process where a model is trained, packaged, version, deployed to production, and then you would have a monitoring system that tracks when the metrics of the model degrade. So you could track, just like you did in training, the accuracy score and the recall score and the AUC score. You can track that for production models and then trigger an automatic retrain. What you would do this because you want to be as impactful as possible to the business. And you as data scientists are most impactful when you're solving new problems and designing new models. You're not as impactful when you're maintaining models that will maintain the same state of the business. So these automated processes are great. It will save you time and to make sure you're as impactful as possible. We would imagine that the model quality will look like this if you are doing such a process. However, in reality, sometimes it degrades even further. It takes a very long time to degrade in these. You could get a graph like this. And the reason why you can get a graph like this is if you use the same metrics you did in development as you do in production, you are going to have a very long lag to identify when a model is drifting. So let's think about Bob's model here. He's predicting if a customer that signed up within the first few days is going to activate 90 days later. So there's a very long time until you find the true label of something that Bob predicted, up to 90 days. And that's, I mean, usually unacceptable for a business to wait that long and wait for their models to degrade all of the time until they find out that is the case. So a solution to this is to use a proxy metric. Like, for example, you could look at the distribution of the predicted variable, and if the distribution of the predicted variable changes, then that could be an indicator that the model quality is going down. And you can identify distribution instantly instead of waiting for all this time, a very long time to find the true label. All right. So recapping the lessons. Lesson 1 is don't chase perfection. Keep it simple. So good enough, fast enough. Lesson 2 is ensure that your feature creation is robust against changes in the underlying data. Lesson 3 is beware of locality, seasonality, and sampling issues. Lesson 4 is if you deploy once, you're going to deploy again. And lesson 5 is the model performance metrics used in development may not be sufficient for performance monitoring in production. thank you for listening, and I'm gonna see if I have any questions.
Awesome. Thank you so much, Mo. I hope none of those points were directed at me, but I learned lots. Again, as Mo mentioned, please feel free to use the Q&A feature or the chat feature to submit questions. We have a couple minutes to spare to pick Mo's brain about data engineering and his points that he brought, which are very insightful.
If if this was too much information, very quickly, there is a blog that I posted up. You can see it in retina.ai/blog, and it basically goes through all of these problems again, and it highlights the solutions one at a time, where you can see them in a slowed down fashion. Let's see, we have one question. Can you clarify what you mean by model drift being a good thing? I always thought it depends, since it may warrant prompt retraining. Yes, frequent model drift, why did I say it's a good thing? Well, coming back to this graph here, so you, as a data scientist, you want to impact the business, and you impact the business. Another word for impacting the business is change the business. So you deploy your model to production in an effort to change the business to the better. And what happens is the business uses the predictions of your model to change itself to the better. So they could sell to more customers, or they could keep customers from churning, or they could expand their customer base. But because the business changed, the underlying data set that you use, the state of the business, also changes. So your model will degrade. So degrading is good here for the business, because the business did benefit from your model and it did change. And therefore you get model drift. So model drift seems bad, but it's actually a really good thing if you think about it from a business perspective.
And Mo, it looks like you have a question in the chat. Do you see it?
I'm trying to find it.
Happy to read it to you also, if that makes it easier.
No, I got something. All right, so if the distribution of the predicted variable is seen to change, how best would you recommend to update your model, or the first thing you would do to address this change in distribution? So if the distribution of your predicted variable is seen to change, you can identify that faster. Oh yeah, you can identify the distribution of your predicted variable immediately and use it as a proxy for your true label. So I wouldn't recommend doing, you pretty much can't do this in development, but this is something you can do in production, because you want to monitor for drift, and you want to monitor for drift as early as possible. So you would have to rely on these proxy metrics to get drift. And you can identify these distributions by just having like a simple monitoring script that checks, okay, how many of this class am I predicting, and how many of that class am I predicting? And if things go above some sort of threshold that you set, you can prompt a system to say, oh, there could be a problem here. So this is something we didn't do in development, but in production, that's a very good proxy for long cycles until you get your true prediction. Let's see. I have some more questions. Okay, I have a follow-up question. I can think of very few other cases. Perfect model drift is ideal. Frequent model, yes. So I have a follow-up question saying, can you think of a few cases where frequent model drift isn't necessarily ideal? Yes. So if, again, it depends on the base problem and how fast the business changes. So let's say your model is a computer vision model that predicts, that identifies objects. You would hope that objects don't change over time very quickly, so you can assume that the model quality for that type of model will not drift fast. It will drift very, very slowly. So if you have a model that is a computer vision model, or if you have a model that, let's say, an NLP model that translates languages should not change that fast, and therefore your distribution shouldn't change very quickly. And model drift, if it happens quick in these cases, then that's very bad. I hope that answers it. Oh, okay, let's see. I have more questions. Let's see. What's causing the model quality to increase over time? Is it the change in the metrics? So looking at this plot, this step change that happened is when they retrain the model. So here, in the first instance, you're catching the model drift, quality drift very quickly, and then you're retraining it, so there's no step change in the model quality. So the model quality seems to be constant over time. Whereas here, the model is allowed to degrade a lot until they capture it, even though they have metrics that say if it degrades below this AUC retrain, the actual quality is going down lower because they can't identify it fast enough. So this step change here, back to the norm, is the retraining process. So the model degrades and they retrain it, it goes back up, and it degrades and they retrain it, it goes back up again. More questions?
Hey Mo, how about we'll do 2 more questions, and then we'll let everyone else who asked questions to reach out to you afterwards.
Yes, sure. Let's see. In mind. Yes, that's true. TV models shouldn't drift fast.
And Mo, make sure that you read out what you're reading, just because obviously nobody can see the question that you're addressing.
Yes. So I had another follow-up saying that they're very happy to hear that computer vision models don't drift very quickly. Yes, and that is the case. It all depends on the underlying problem you are solving. And I should say, it could be a very fast model drift could happen if you're predicting, like if you're detecting fraud. If your model is for detecting fraud and identifying fraudsters, fraud and scam changes very, very quickly, and therefore you can expect your model to go to 0 very rapidly. That's on the other side of the scale. Is it possible to catch model drift too early? It depends on the tolerance for the business. So coming back to the first lesson, don't chase perfection, good enough. So if the model is drifting and it's still good enough, it might not be worth the resources to train it. Because when you train it, you're spending compute costs, you're spending engineering time, and you're risking things changing. Every time you make a change to your system, you're risking things breaking. So if the drift is acceptable, it doesn't need to be, there's no action needs to be taken. You just need to monitor it. So having a dashboard that an engineer can look at and see, oh, now I'm predicting at 80% of my initial performance, but that's still okay, and that's perfectly fine. So that's a business decision they have to take. And then my last question is, what will be some signals to look for so you know is time to remove your model, end of life, remove your model from production? Yes, I think that's great. So if you're retraining and you're looking at your monitoring system and you're not getting the same quality, that could be an indicator that the underlying data has changed more than your model can handle. So let me give you an example. Part of monitoring is not a fully automated process. So if I go back to here, this loop that goes to model monitoring at the very end. Model monitoring seems automated, but that is not actually the case. We need operation engineers, and you need the team to constantly look at these metrics, because even if you have an automated process that triggers, you need to have someone identify when it's no longer needed. Because a lot of things can go wrong in production, and if you have a monitoring and logging system that is robust, you can identify these quickly. So that's an example of when you should take it away. If it's not performing as needed, or if there is a business, if the business changes more than the model can handle. Great.
Sorry, I was muted. Awesome. Thank you so much, Mo, for answering those questions. Again, if you have any more questions for Siyang or Mo, we will send out their contact information after this. Feel free to connect with them on LinkedIn. I'm sure they're more than willing to answer your questions. I also want to say thank you again to everybody who came to attend. I really appreciate it. Again, I hope you're all being safe. I hope we can give a warm applause to Mo and Siyang virtually, and also Carolyn and Taylor for helping set this up every month. This is always really great. I always learn something new when I attend, and I hope you do as well. And I hope to see you guys next month also. Thank you so much. I hope you have a great night.